Ladies and gentlemen, boys and girls, welcome to TDO. Name is TT, and today we're gonna be doing the first angle and the third angle orthographic projection. So let's get right on to it. But firstly, let's start by determining the difference between the first angle and the third angle orthographic projection symbols. Alright, so here it is. Right here we have a symbol for a first angle, which you're gonna be seeing a lot if you're doing engineering drawing, and then on the bottom we have our third angle orthographic projection symbol right there. These are not just shapes. Basically what you are seeing here, this is the front view of that object, and this is the left view of the object right here. So the left view of this object is positioned at the right hand side of the front. That's what a first angle does every time. And then on the third angle, in this case we have the front right there, and then the circles are on the left hand side, which means now this is the left view. Even there is a left view, but the only difference is that on the first angle the left view is positioned on the right hand side of the front, and then on the third angle the left view is positioned on its original left hand side of the front view. This tiny circle is the circle right there on the front of the thing. So this tiny circle that you're seeing here is that distance from there to there. That diameter is the smaller circle, and then the bigger one is the distance from there to there. So that's how you differentiate between the two. So let's carry on with the lesson. So here we have an isometric representation of this bracket right here. Let's call this shape a bracket. So now this is represented in a first angle orthographic projection. Why am I saying that? Is because we have the left view right there, and then you have the front on this side over here, and then the top view is what you're gonna see when you're looking at this thing from the top. So the left view is like this. So if we were to see the front view of the object, this is the front view of the object right here. And then you shift to the left hand side to see the left view. This is how the left view appears like. And then you want to see the top. This is how the top view appears like. And then this is the isometric representation of the bracket right here. So now let's talk about the positioning of the views when we are supposed to draw them in a first angle or in a third angle. So every isometric view that they show you and then they tell you it's in a first angle, you should immediately confirm that this side that is here is the front view, and then the one that is here is the left view, and then the top is always the top. Why am I saying that? Is because the first angle is always coming with the left view. It's not likely the first angle to come with the right view. It always gets represented by the left view, just like its symbol say. Alright, so let's talk about the positioning of the views now. The positioning of the views for the first angle is two views at the top and then one view at the bottom. So you have a Cartesian plane like this. You always produce a Cartesian plane when you want to place your views. So on the first quadrant, you place the front for the first angle. And then on the second quadrant, just like the symbol for the first angle says, there's a front, and then on the right hand side of the front there is a side view, and that side view is what is a left view for the first angle. And then on the third quadrant there is a top view. That's how you represent the views in a first angle. So let's go and analyze the views and come back and plant them right here. So we have our bracket right here, and then let's start by analyzing the front view. So since this thing is represented in a first angle orthographic projection, this side right here is a front view. So which means if you're looking at it from this side, you are standing here, you are looking at this thing directly. Which surfaces are you gonna see? You're gonna see all the surfaces that are facing at you, which are these surfaces right here. This is how you're gonna see them. So this is what you're gonna see. So you go to your first quadrant, you place the front view. So right there, you have your front view over there on the first quadrant. And then just like that, you are done representing the front view in a first angle. And then let's shift over and represent the side view, which is the left view that is going to be stationed at the second quadrant right there. All right, so here we are again. We have our object here, and then we want to represent what? The left view now. So which surfaces are you going to see when you're standing at the left side of this thing? The left side is this direction right here, is this station. This is the left side. So what you're going to see when you're looking at this thing from the left view, this is what you're going to see right there. If we were to focus on the left view, this is how it's gonna look like right here. So you take this shape as it is, you go and put it where? On the second quadrant where you are supposed to place your left view. All right, then here we are. We have the second quadrant empty and ready for the left view, and then you project the left view from the front view, which is something exactly like that right there. This is how you come up with the left view. You put it right there. Don't worry about how to draw it right now. We're gonna get to that after I'm done with the explanation. And then we are left with the last part, which is the top view, which is supposed to be stationed at that quadrant right there. So let's go and analyze the top view, and then we'll come back and place it right here. All right, then back to our bracket. We focus on the top. Which surfaces are you gonna see when you're looking at this thing from the top view? These are the surfaces that you're gonna see. These are the only surfaces that you're gonna see when you're looking at this thing from the top view. Now, that surface right there, you can't see it because it's running under this surface right here. It's equal to this surface right there. So it's underneath it. So if you look at this thing from the top, you cannot see that surface right there. That is why you cannot show it on your top view. So if we were to focus on our top view for this thing, this is how it's gonna look like. You're gonna see a bunch of rectangles stacking on top of each other. One, two, three. Which this one is the first surface, that one is the second, and this one is the third. There you go. And then you take this thing, you get the dimensions from it, you go and put it where you're supposed to place the top view. So now you're gonna have your top view right there. That's where your top view is gonna be stationed. It's simple as that. The top view is projected from the front, and then the side is also projected from the front view. So this is a representation of a first angle. This is how you represent a first angle orthographic projection. There is always going to be a horizontal plane. The first quadrant is for the front view, the second quadrant is for the left view, and then the third quadrant is for the top view right there. All right, now for the third angle orthographic projection, it's another story. But still you have your horizontal plane, and then the positioning of the views differs because the third angle represents the right view. It comes with the right view. It gets the top, the front, and then the side. It's a right view. It's no longer the left view now. So the positioning of the third angle orthographic projection views, it's differ from the first angle. On the third angle, you put the top view at the first quadrant, at the top right there. And then at the bottom, you put your what? You put your front view. And then on the right hand side of the front view, you put the right view. It puts everything as it is. That's what a third angle does. So if you were to describe the difference between the third and the first angle in a simpler way, is that the first angle has two views at the top and one view at the bottom of the horizontal plane. The third angle has two views at the bottom and one view at the top. It's an inverse. So now the top view is gonna be right there. At the bottom, there's gonna be a front, and then there's gonna be a right view right there. So let's start by putting a front where it's gonna be, right there. So in the third angle, even the representation of the isometric view changes. This is the representation of the first angle orthographic projection of an isometric view. And then when it comes to the third angle, the isometric view for the third angle, this thing is gonna have to turn and look like this. Because this, it's still your front, yes? Because this is a third angle now, we are no longer showing the left view. We're gonna have to show the right view. And then since this is the front view right there, the right hand side of the front view is this side right here. So this is the right view now, right there. The top doesn't change. The top is still the top. The only thing that changes is the positioning of an isometric view, and then the side that gets exposed on the isometric view. Now the left hand side is hidden, it's over there in behind, you cannot see it. So this is the third angle. So if they were to give you an isometric view just like this, and then they tell you the orographic projection of it, if they say this is the third angle, you know that okay, since now it's a third angle, my front is over here because the third angle has to expose the right hand side. So in order for me to see the right hand side, the front has to be here, and then the right hand side of the front has to be on this side right here. So automatically you know that if they say it's a third angle, this side is a right hand side. But if they position it like this, and then they said this is a first angle, you know that the first angle is going to be exposing the left view. So if you are given an isometric view like this and then they say it's a first angle, you're going to analyze it like this. So since this is a first angle and the first angle has to expose a left view. So in order for me to say left view and the front view, where am I going to be labeling the front? This is going to be your front view now. Because in order for you to see the left view, you're going to have to see the front right there, and then on the left hand side of the front you see the left view right there. So this is going to be your left view and this is going to be your front view in a first angle. But it depends on the isometric view that is given to you and the projection symbol that goes along with it. That's how you interpret the whole thing. So all right, back to the third angle now. So this is a third angle, this is the front, this is the right view. So let's go and put the front where it's gonna be. So the front for the first angle is not gonna differ from the front of the third angle. It's gonna be the same because you are gonna still see all these surfaces when you are standing in this position right there. So you come and place the front where it's supposed to be on the third quadrant right there. Your front, it's gonna be there. And then the top view also doesn't change. You're gonna still see the same surfaces that you were seeing on the first angle. So you go and place the top view. On the top side of the front, there is a top view right there. There is your top. And then on the right hand side of the front, there's gonna be a right view right there. So if you were to project the right view from there, this is how it's gonna look like. Exactly like that. So you have two views at the bottom and you have a single view at the top. This is what we call a third angle orographic projection. If we were to go back to our bracket right there and click on the right view, this is what it appears like. But on the first angle, the shape of the right view and the shape of the left view are the same, but the positioning is not the same. This is the position of the right view. And then for the left view, this is the position. The left view is pointing that way. And then the right view is pointing the opposite way right there. That is why you see it on the side view of the front like that. This is how you differentiate between a first angle and a third angle orographic projection. Alright, here's the view of the casting. So remember, they required you to draw a front view from the direction F. There is your F. And then they wanted you to draw a top view from direction T, and then obviously the left view from direction L. So what you need to do, you don't have to worry about anything because this is the most basic orographic projection. This is the most simple stuff. And then after this one, we're gonna go over and explain the more complex one. But when you're given something like this, an isometric view, like it's just copy and paste. Everything is copy and paste. The only thing that you need to be aware of is the views, and you have to use a little bit of your imagination. So they want the front view obviously from the direction F. Alright then, let's go over and confirm what we're gonna see when you're standing at that F point. So that's you. You are that F right now. The only thing that you're gonna see is the thing that is facing directly at you. So you're standing right there. What's the first surface that you're gonna see? Is that surface right there, that rectangular surface. That's the first thing that you're gonna see. And then, are you gonna see that side? No, you're not gonna see that side because that's on the left hand side. Are you gonna see that surface? No, you can't see that surface because it's on the top side. It's on the top. You're only gonna see that surface when you are looking at this thing from the top side. So now you already confirmed that this is what you're gonna see when you are looking at this thing from the front. So every other surface that is parallel to this surface is what you're gonna take from here, and you're gonna draw it where you're supposed to put what? Your front view. So you have this surface. Where is the second surface that is parallel to this one? Another surface that is facing directly at you. That 7 units tall rectangular shape right there. So now you have two rectangles. This surface is parallel to that surface. They are both facing at you. So that's the second thing that you're gonna see. And now, what's the third parallel? There. You have the third parallel there. And then you go over and over again. You look for the fourth. Now, before you confirm that this is the fourth and the last surface, that's actually wrong because you have that surface there. That's like a groove right there. It's inside, but it's still parallel to which surface? To this one. It's in a rectangular shape, just like all the other surfaces. And then goes the last one. So basically what you're gonna see when you're standing at your front view, you're gonna see rectangles stacking on top of each other all the way up to the top side. So that's what you're gonna see. So you take it as it is, you take the dimensions, you transfer it to where? To the space where you're supposed to put your front. Now let's go and do that. Alright, now the first thing that you do before you put your views, you have to create a space and borders for your views. So this is like a Cartesian plane, it's a cross. So when you're creating this cross, you have two parallel lines going to the downside, and then you have two horizontal parallels. And then the space in between those two lines is 20 millimeters apart. And then the space in between those two verticals is also 20 millimeters apart. Let's try and map where we're gonna put our views. This thing is in first angle, right? So we're gonna have two views at the top and a single view at the bottom. By that I mean we're gonna have a front right there on the first quadrant, and then on the second quadrant you're gonna have the what? The left view. Obviously the front distribute for the left, and it also distributes for what? For the top. So the front is here, at the bottom side we have the top view, the right hand side you have what? You have the left view, because this thing is in first angle. So since we're gonna start with the front view, you already know now that you're gonna put your front view where? On the first quadrant. But where should it start? Should you put it anywhere along this line or anywhere along that line? No, you don't just pick and choose where to put it. But every view starts at the corner. So the bottom right corner of your front view, it should be that corner. It should be right there. So which means every dimension that starts from your bottom right, it starts from this point right there at this corner. And then the bottom left of your what? Of your left view, it starts at that corner right there. That's why you have the two parallels to keep the drawings apart. So the bottom left corner of your left hand view is gonna start there. The top the top right corner of your top view is gonna start where? There. As this thing shows you, here we have the bottom right corner, there we have the bottom left corner, there we have the top right corner. Because there is a front, you take the bottom right corner of the front view, you put it there. You take the bottom left corner of what? Of your left view, you put it here at this bottom left, right there. So let's go back to our structure. Here's your structure. Since we're gonna start with the front view, we are right there. And remember, we said for the front view, we take the what? The bottom right corner. Where is the bottom right here when you're looking at this thing? This is the left hand side. This is the bottom left corner. There is your bottom right corner right there. You take that bottom right corner, you go upside by 18, and then you shift to the left by 37. So there is that bottom right corner. You take your ruler, you go 18 units to the top side, and then 37 to the right. And then you create your what? Your first surface that you're going to see, which is that rectangular surface right there. So you go back to your structure, you analyze for the second one. The second one is there, that is pushing up by 7 units. So it goes up by 7 units from the top level of the what? Of the first one. Which means from the top of the 18, you should also push up by what? By 7 units. Neglect that surface over there. That surface, you're not gonna see it. So when you're standing right there, you're only gonna see rectangular shapes staking on top of each other. It will be like this rectangular shape, it's on top of this one when you're standing from your front view. You're not gonna see that thing. You don't include that thing because it's only visible when you are looking at it from the top side. So you go back to your drawing. You're supposed to push up by what? By 7 units. You take your ruler, you go up by 7 units, and then after that 7 units, you complete your what? Your rectangular shape. Just like that. Now you're done with the second one. Let's go up to that one. How high is that one? It's 15 units. Now we worry not about the length because all these shapes in length are equal to that to the first one. So everything is 37 long. And then the only thing that you consider now is the height because now we were from the 7 and then from the 7 we push by 15 units up. That one is 15 units high. So you go back to your structure, you pull up your ruler, you go up 15 units right there. And then you already know what to do after measuring. You complete the shape, which is the rectangular shape. Right there. There you go. Now, you go back to your structure, the view of your casting. After the 15, we have that hidden rectangular, we have another hidden rectangular shape right there. Another rectangular surface that is hidden. From the F side, you're going to be able to see inside that groove right there. You're going to be able to see inside that open space before you get to the top side. So, how high that is pushes? It pushes also by what? By 7. And then we have the last one that also pushes up by what? By 7 units. So we're gonna have two sevens, and then you go back to your working space. You push up by 7 units, and you push up by another 7 units, like that. And then the next thing you do, same thing that you were doing all along. You close the what? Your rectangles. You close your shapes. Right there. You go back to your isometric view, you confirm your view. How many rectangular surfaces do we see here in our front view? There is one, there is two there is three, there is four, there is five. There is five right there. It's one, two, three, four, five. You go back to your structure, you count your rectangular views. One, two, three, four with the hidden, and then five with the last. So now we can confirm that our front view is complete. So now it's up to you. After constructing the front view, it's up to you if you whether you shift with the left or you go down to the top view. It's up to you because every dimensions they are given here. You can create the left view and you can also create the top view. Alright, now you have something like this. You are done with the first quadrant whereby you are supposed to station your front view. You shift to the left view or you shift to the top view. It's up to you. You can start by any of the views because the dimensions are given. So let's go over and produce the left view. So now here is the case after you are done with the front view or after you are done with any other view that you decided to start with. You go back to your structure. Now you are no longer stationed at F. Now you are stationed at what? At L there, at that left hand side. So now the only thing you can see is the left view. So what can you see when you are looking at this thing from the left hand side? You're gonna see all this shape right there, all that surface. There is one huge surface that you're gonna see. And remember, we said on the left view, we're gonna put the what? The bottom left corner at the bottom left corner. So this bottom left corner should be matching with what? With our bottom left corner on our Cartesian plane. And then we're going to start measuring the dimensions from the corner upwards and from the very same corner to that side. So since this is the bottom left, you measure from the bottom left to the right hand side. So now you can see that going up, this thing in total is 55 units. So now it's up to you. Either you come here, you remeasure the 55 units, but that's not necessary. The reason why I'm saying that's not necessary because you've already figured out the total height of the component while you were drawing what? While you were drawing your front view. So the only thing that you do now, you project each and every measurement that you produced when you were busy with the front view. You project this dimension to the left hand side, and it doesn't matter the length of the line because it's a construction line, so it doesn't matter the dimensions. You can just stretch it to as far. You're gonna have that point over there. You project that point also horizontally. Each and every dimension you marked when you were producing your front view, you're gonna have to draw it to where you are supposed to place your left view. So now you are done transferring all the points except for the bottom part. That bottom corner is already there. You already have that faint line of yours. These are the new created faint lines because everything that you do for the construction, they should be in faint line. The only thing you outline, remember, is a final product. Let's go back to our structure. We have that bottom left corner right there. We already went up by 55 because we projected the total height from where? From the front. So from that 55, you shift to the right hand side by what? By 18, because remember, we're trying to come up with this whole shape right there. So it start by going to the right 18 units. It started from where? From that bottom left corner. And then you have your what? You have your total height of 55 right there. That is your total height. And then from that total height, it shifts 18 units to the right hand side. So you go to the right hand side by what? By 18 units. Obviously, from this side, it drops down to what? To that 7 over there. So you go to your front. Where's the first 7? This is the first 7 right there. It drops down with that 7. And then it goes straight down. It ends at the 7. And then you go back to refer from your structure, and then from that 7 it shifts back inside with how many units? With 11 units. There is that 11 units right there. It shifts back inside with 11 units, and then it goes down with another 7, and then it comes back out with another 11 units. So you transfer those over there. It goes in with 11 units, and then it drops straight down to the 7, and then from the 7 it goes out again by another 11 units. So now after doing that, you go back to your refer space where you're supposed to refer. And then from that 11, it pushes straight down with how many units? With the 15 units. But there's no need for you to measure the 15 unit because already there's that 15 over there, which is the very same 15 that we are dealing with right now. So it pushes straight down to where? To the 15. Our projections are very helpful. So you see how the projection part helps you out. It saves time. There's no need for you to go back and remeasure everything. So, and then from that 15, you go and refer. We are at there now. So, because there is the 15. And then from the 15, we shift to the right hand side by 22. So we push to the right by 22. And then we drop down a step of 7 units. There is the step of 7 units. So now we're just following the trails. There is our 7. You just take your ruler, you drop this thing down to the 7 level right there, and then you go back, you refer. We are right there at that corner right now, and then from there you push to the last corner with what? With 30 units, and then it drops down to the floor, and then you go back. You have to push with 30 units to the right hand side. You push far by 30. From the 30, it drops down to the end. We started here, we went up, we came all the way around, now we are there. So this was our starting point. So which dimension is left from the starting point? Because now we only have to close this thing from the base. From our starting corner over there, you have to push to the right side by 33 units. So this is our starting point. You push to what? To the right side by what? By 33, by 33 units. And then from the 33, we are there at the 33. We have to go up, go to the right, go down again, and then go to the right. We meet our endpoint that we created previously. So you push up by 7 units, and then from the 7, you shift to the right 30 units. And then from that point, you already know where it goes. Drop straight down, and then from straight down, it meets with the end point right there, which is the bottom right corner. This highlighted shape right there is the left view. It's the very same thing that you see when you are standing at that L position. You're gonna see this shape, the left view. Now let's shift to the last part, which is the what? Which is the top view. And the top view is gonna start from this corner, the top right corner. So you go to your structure. This is your top view. You are standing there at that T. You are a T up there. So where is your top right corner when you are looking at this thing from that T position? There is your top right corner. Right there is your top right corner. And then this is the top left corner. This is the bottom right. This is the bottom left. So the top right corner, you shift this side by 37, you shift downwards by 18. But remember now, you have to make things simple by projecting from the previous views. So now you have to project that point. So there is our top right corner right there. We have that 37 already. If you are looking at it from the top perspective, this goes downwards because that is your top right corner. And then from the top right corner going that direction, it's downwards. And then from the top right corner going this direction is leftwards. So you go down by 18, you create that surface because that's the first surface that you're going to see. And then which are the parallel surfaces that you're going to see also? It's the second one right there because it's parallel to that one. You're gonna also see it, and then you're gonna see that the last one right there. There is no other surface that you're going to see. So now you shift down 18 units. You take your ruler, you mark 18 units. After marking the 18 units, what shape are you seeing? You are seeing the rectangular shape. There you go. You are done with the first one. Now you shift to the downside. You were here, you are done with this one. You're going to the second one that you're going to see. So now you shift 22 units to the downside for the second triangular shape. You shift 22 units, you pull up your ruler, you mark 22 units to the downside, and then you complete your rectangular shape. So there is your 22 units to the downside, and then you complete another rectangular shape. You close it. So the last one goes down by 30 units. So you also take your ruler, you mark 30. After marking the 30, you conclude your rectangular surface. Just like that. And you are done with what? With the top view. And now you are done with what? With the autographic projection. You are done with the whole question. So, ladies and gentlemen, congratulations. You are done with the first angle autographic projection question. So,